Welcome back to the channel. In today's video, we will be designing a binary counter using Vivado IP. Whether you are a beginner or an experienced FPGA designer, this step-by-step tutorial will guide you through the entire process from creating the project to simulating the circuit. If you are interested in digital design, VHDL coding, Verilog coding or FPGA development, make sure to watch the video till the end. So after creating the Vivado project, we will dive into the IP catalog and search for the binary counter IP core. The Vivado IP refers to pre-designed and pre-verified blocks or modules which are provided within the Vivado design suite that can be integrated into the FPGA design. They offer the advantage to simplify and accelerate the development process. So the binary counter is a very powerful IP block that will save us time and effort by handling the counting logic. So we found the IP, now we added it to our project, and now we are configuring our IP to be according to our design. So as you can see, we have taken some signals. These are the clock signal, clock enable signal and reset signal. So now we will also make these signals external so that we can check their values or we can provide the signals to them. So we are making the signals external to verify the design. So we will set the parameters like counter width, counter direction, and by the end of this step we will have a fully customized counter that is ready to be integrated into our design. Note that this is a block based design. So now let us make the signals external so that we can provide the input to them. So this is the reset signal. This is the active high reset signal. We also have a threshold signal and we have a output signal. So there are three input signals, one of which is the clock signal. Then there is a clock enable signal. There is a reset signal which appears as SCLR in this design. So we can also rename these signals. Then we have two output signals. One is the threshold signal and one is the Q. So this is a 4-bit binary counter. That is why this Q signal is from 3:0. So we can also rename them. So now I am giving them names that are used commonly in the counter design. So the reset signal, then there is the clock enable signal, and so on. So this clock enable signal will enable the clock only when this counter is to be used. So it will save us power consumption because the clock will not be always enabled. It will be only enabled when we want the counter to work. So we have set the count mode to be as up counter. We can use the same IP as down counter also, and we can use the same IP as both up and down counter also. But here for simplicity we are taking it as like up counter. So after this step is complete, now we will try to generate the necessary output products including the HDL wrapper. And finally we will run the simulation. So first we will generate the HDL wrapper. Using the create HDL wrapper, we will let Vivado to manage and auto update. So this is a very automatic process. This is a CAD based design, so computer is managing everything for us and we don't have to worry anything. So this is a very simple tutorial. It can be implemented by both the experienced as well as the beginner FPGA designers. So after managing the wrappers, you can see the wrapper has an extension of .v. So this is a Verilog based code, but we can also generate a VHDL based wrapper also. So we will force the clock. Now we are simulating to ensure that everything is working as expected. So if we see the applications of counters, counters are used in timing and synchronizations. They are often used to create time delays and synchronize events. Then counters are also used in state machines to cycle through states based on clock. Then counters are also used in frequency division to create slower clock from high speed clock. So as you can see, we have simulated the design, and the threshold signal goes to 1 whenever our count approaches D. So we set the threshold value to be D. So the threshold signal goes to 1 whenever the count reaches D. And you can see we have not reset it. We have not reset the counter. If we reset the counter, then the count will be reset to 0. And we have used the clock enable signal. If we do not provide the clock enable signal, the counter will not work. So I hope you found this tutorial helpful. If you did, please give a thumbs up, subscribe to the channel for more FPGA and digital design tutorials, and leave a comment if you have any questions or suggestions for future videos. Thank you for watching, and I will see you in the next video.